the same polynomials which I took in the previous video, in which we were discussing about the HCFs of those, and now I'm gonna take those same polynomials and take the LCM this time. Okay, now let's write them in its prime factorized form like we did in the previous video. Let's do that. Let's do the same thing. AB cube, and these are going to be written as, now this 42 is 2 into 3 into 7, and now a square, that is a into a, and b square will be b into b. Now the same with 48, it's going to be 2 into 2 into 2 into 2 into 3, and then a and b cube is b into b into b. Now to take the LCMs, what we usually do is take everything into consideration, like every number should be at least considered once. So let's see. Now here we have a two. I'll just circle the ones which we will be writing only once. So we'll be writing 2 once because it's already common in them. So let's write 2, and 3 is also common in them. So we'll write into 3. Then a is also common, so into a, and there are 2 b's common in both of them, so that's into b squared. Okay, now this actually works for HCF if you're looking for the HCF, but for the LCM, as I told before, every number should be taken into consideration, every variable and every number. So here the numbers which we are left with are 7, right? We're gonna write into 7 here. There's a here into a, and there's 2 into 2 into 2, that's 2 cube, which is 8, and we have into b. Now to write this down, let's write 2 3s are 6, 2 7, I mean 6 7s are 42, and 42 8s are. On to the second question, we have to find the LCM of the same two polynomials which we did when we were finding the HCF of those. So to start, we have to write them in its prime factorized form. 96 is 2 power 5 into 3, and then we have x minus 1, so that will be into x minus 1, and then there's x plus 1 squared. We're going to write x plus 1 squared into x plus 3 cube. Okay, now the next equation will be written as this one here, will be 64 is 2 power 6. I'll write 2 power 6 into the given things, and x square minus 1 is basically x plus 1 into x minus 1, and we have into x plus 3, then we have into x plus 2 square. We have x plus 2 whole square. Okay, now if you remember, to find the HCF, we have to find the LCM, sorry, we have to look for whatever there is common, and I mean we have to consider common ones only once, and the non-common ones should be included as well. Now to start, we have 2 power 5 common in both of them, right? 2 power 5 is common in both, but then there'll be an extra 2 here. So now then let me write it this way. I'll write 2 power 5 into 2. So 2 power 5 is common. I'll write 2 power 5 once, and this is done. And then there's x minus 1. There's x minus 1 here and here. So that will be into x minus 1. Then there is x plus 1 squared and x plus 1. Then I'm going to write x plus 1 once, and I'm going to keep this, I'm gonna box that, and this will be powered 1. And next I have x plus 3. I have x plus 3 common as well. Then I'm gonna write into x plus 3. Then I'll be remaining with x plus 3 power 2 over there. Then I have this is done. I'll circle it, and I have x plus 2 whole square, which is not common in anywhere. Now let's write the non-common ones. I'll write it with a different color. um, so the non-common ones here are, there is 2, there's 3. I'll write 2 into 3, I'll write it 6 directly. Then I have x plus 1, that's into x plus 1. Then there is x plus 3 whole square, so that's x plus 3 whole square, then into x plus 2 whole square. Okay, now let's write this down the way it comes. So now it's going to become 2 power 5 is 32, and 32 6 are 192. Yeah, it's 192. It's 192. Okay, 32 692. Then I have x minus 1. So I'll write into, I'll not write into, so I'll write it directly, x minus 1. And then I have 2x plus 1s here, so that will be x plus 1 whole square. And I have 2 x plus 3 into x plus 3 whole squared, so that's going to become x plus 3 whole cube. Then I have this remaining, which is into, not going to write into, it is x plus 2 whole square. So this here is our LCM of the polynomials here and here.